Good morning and welcome to this week's version of the Long Coffee Break. My name's Jason Long. I'm one of the sales engineers with Long Building Technologies out of the Denver office. And today I'm really excited to be joined by Jacob Wolf. He's with M&M Carnot, and we're going to talk about some really cool technology they have utilizing natural refrigerants. So thank you for being with us today. Jake, can you go to the next slide? So the first thing I just want to share is that M&M Carnot has been around for 50 years, specializing in industrial and commercial cooling. So they're not a new company. This is not new technology. But what is relatively new is taking this technology using natural refrigerants and primarily CO2 and applying it to more traditional HVAC applications. So the reason we're really excited about that, and they've started to expand the use of that in the last 10 years really in Canada and are now growing in the United States. And we're excited to be one of their partners for a lot of different reasons. But Jake, if you go to the next slide here, one of the main reasons is that if you've participated in some recent coffee breaks with us, we've started to talk about this larger trend in the market that we're going to be going through over the next couple of years to phase out and phase down some of the current refrigerants we've been using for a long time, namely 134A and 410A. So over the next 3 years, this is going to be happening, and some states are choosing to move quicker than others, and it's just going to create some challenges when it comes to the design and implementation of our construction projects. So having access to technology and product offerings from companies like M&M Carnot that are utilizing natural refrigerants with a GWP of 1 and don't have any risk of phase out or phase down is a really cool opportunity. So with that, I'm going to turn it over to Jake to share a little bit more with us about the technology.
Excellent. Thank you, Jason. So with a CO2 system, we have 3 modes of operation. We have a transcritical mode, we have a subcritical mode or condensing mode, and then we have a free cooler or an economizer mode. And with that, the transcritical compression cycle is going to be the least efficient of the 3 operation modes. And essentially, it's going to be roughly at above 88 degrees Fahrenheit, and it's where we're above the transcritical line, where we're cooling the gas, and then any flash gas that comes back off, we're actually re-cooling it through the gas cooler and sending the liquid to the evaporator. So at this point, the refrigeration system is running open to be able to meet the load. Please note there's also a possibility to use an adiabatic gas cooler to eliminate a lot of the transcritical operation. It's also important to note that this is a normal operating mode for this system. Next is the subcritical mode. So this is when the temperature reaches roughly below 88 degrees Fahrenheit. And at this point, we're condensing. It's important to note that while we're condensing, this is going to be more efficient than a normal synthetic refrigerant system. So we want to be in condensation mode as much as possible. Next is the free cooling mode, and this is the most important, and it's also it's a really energy efficient mode for us. At this point, once the outdoor ambient goes low enough, we start to see the gas cooler act as the compressor, and we're in full free cooling mode. So essentially using thermosiphon or gravity or refrigerant migration, we're just using that temperature difference to recirculate the CO2 throughout the system and enable free cooling. So no circulation pump is required, simply gravity. And the higher the vertical distance of the condenser up higher above the evaporator, the better the free cooling will be. It's important to note that although CO2 is a high pressure system, roughly 1740 psi, one of the benefits to that is we get, for every degree Celsius, we get a 30 psi difference in pressure, which makes it very favorable for this system. And again, no recirculation pump is required. So the Denver performance, we can see at above 84 degrees, this is the transcritical operation. we see here in the blue, roughly 79 to 54, this is going to be the subcritical. And then below roughly 54, we're going to see this is the free cooling bin hours that we're going to get out of the system. So we can see that we can reach free cooling quite quickly. Different product offerings. So we have two types of standard units. We have an Aquilon crack perimeter unit in roughly 52, 84, 105, 168, and 275 kW, which is coming soon. So roughly 15 tons to 48 tons. And then we have a roughly 75-ton unit coming out. And this will be an upflow and then also downflow. And then we also have a Cumulus in-row unit, which is 40 kilowatt or 11.5 tons capacity with roughly a 100 kilowatt system coming out soon as well. And this is a split system where we have a transcritical system inside, and then we're delivering CO2 to the rack. And it's split with a plate heat exchanger. And we could save here, we could see here that we have the units on top, there's a heat exchanger inside, and then there's no water going to the rack, it's just straight CO2. So with this system, we're also able to get free cooling via the thermosiphon. And so this makes it a very, very energy efficient system. And then alternatively, we also have an option where we have a water cooled rack system as well. So we could bring chilled water with the heat exchanger here and then deliver this to the rack. Please note that these systems are all one rack to one condenser. And the reason for that is if we gang them, then we won't be able to get the free cooling and hence the energy savings from the unit. So this is pictures worth 1,000 words. We have on the top a gas cooler, which is roughly going to be much smaller, maybe 2/3 the size of a synthetic condenser. And we have on the right, we have a in-row unit. And this in-row is a 40 kW unit with a 12-inch cooling rack. Next, I'd like to touch on some electrification. We have heat pumps with heat recovery. This is becoming very, very popular. And with this, we're able to heat domestic hot water and in some cases, take out a natural gas boiler. It is important to note that with this system, we are the only ones that also can give a free cooling cycle as well, which we have patented as the rain free cooling cycle. With this product, we can reach up to 171 degrees water at 30% or 290 kW capacity. This is all dependent on many variables. Each case will have to be reviewed, but we can look at that for you. And then our standard range is roughly 40-ton increment chillers. And we're selling quite a few of those right now. Note the price difference with CO2 is roughly going to be 1.5 times a system of synthetics. However, the heat that you're able to gain off the chiller is quite dramatic, and it makes it a good payback. This is again a picture's worth 1,000 words. This system had 5 R22 chillers. On the top, we see this is the same picture, but we were able to remove these chillers and then put in 2 80-ton chillers with heat recovery. And in this building, it was able to heat a swimming pool, office space, an ice skating rink was being chilled through there, and then a library was also heated and cooled through there as well. With the installation, one thing that we recommend, you are able to use K65 copper, but we recommend stainless steel tubing per ASTM A249 304. With this, you can bend the tubing, getting less joints, much less leakage rate than a copper system. And then we recommend an orbital weld around the piping. And we can train technicians, and there's also a lot of technicians in the US that do this. We deal with them every day in the refrigeration market, so we can provide you support with this. But stainless steel is the most robust, and this is what we recommend. With safety rules, roughly long-term exposure limit is 8 hours at 5,000 parts per million. short-term exposure is 15 minutes at 15,000 parts per million. It's very similar to a synthetic refrigerant where we replace R22 systems all the time. The same ventilation code requirements are there. We just recommend that a CO2 sensor be mounted low on the wall. That way you're able to catch any CO2. But the system charge is going to be the same, if not less than a synthetic system. Some of the advantages of Carnot: best-in-class efficiencies. We have economizer cycles for the crack, the in-row, and the heat pumps. We have no circulation, recirculation pump is required, which also saves a lot of energy on that economizer cycle. We have a GWP of 1, so we have no worry of any future regulations. We are able to do very longer vertical pipe installations for gas coolers due to that high pressure differential compared to synthetic refrigerant installations. We have a smaller footprint than synthetics as well. And then our lead times are roughly really low at 24 to 30 weeks. And that's due to because we have a lot of parts out there. CO2 is not new, and there's a lot of manufacturers of those parts, and so we're able to source them. They're all readily available. Some frequently asked questions: do you need a recirculation pump for CO2? Answer is no. Again, through our rain cycle, we're able to use thermosiphon and refrigerant migration to move the refrigerant through the system. Is there a maximum elevation or distance between the evaporator and gas cooler? Technically, no. The higher it is, the actually better it is. For every 1 degree Celsius, we get 30 PSI. Are we able to perform well in high ambient regions? Absolutely. So, your design days aren't that much of an issue. We might have to redesign or look at a certain application if it's really high, but in all, you can work in transcritical mode, and it's the way the system was built. If you add an adiabatic gas cooler, that will dramatically reduce the energy, and that's what a lot of customers actually like to do in some larger process installations that we have. So that's doable. Should you be concerned about the high pressure? Again, it's a 1740 rated PSI system. You do not have to be concerned. There's a relief valve. Everything's UL. CO2 is non-toxic. It's non-flammable, so there's no special requirements there through the EPA. So it's a very simple replacement. How do the sizes of the units compare? CO2 has a higher heat capacity. It allows for a smaller heat exchanger, less charge, and a smaller footprint. And are the components readily available? The answer is yes. CO2 is standard in many industries. Lead times are running roughly 24 to 30 weeks, depending on the quantity of the order. How does the installation cost for CO2 compare to synthetic refrigerants? For a comparable system with an economizer cycle, it's roughly the same. The stainless steel is actually cheaper because you could buy it in longer lengths and smaller diameter. The installation, you require less orbital welds compared to brazing. And our contractors have told us that they actually enjoy it more than a copper brazing. What is the life cycle of the equipment? With stainless steel, 25 years is easily doable. So we have a lot of systems running out there that are creeping up on 25 years, and we don't see any end of life in there. And again, transcritically globally, we can see that in 2008 it started to become popular again due to the Montreal Protocol, and then we can see it explode in 2018, especially in North America as well. And then just to give you some perspective, when we look at it in 2021, it's growing exponentially. And for me, this is the future. And for a data center, for a heat pump application, it is just a perfect refrigerant. So I encourage you to learn more. And then we have case studies upon request. Please reach out to Jason and we can deliver those to you. Again, my name is Jacob Wolf, and I'd like to thank Long & Associates. Thank you for your time. And Jason, I'll turn it over to you.
Yeah, thank you again, Jake. Really appreciate you joining us. And thank you to everybody for spending the last 15 minutes this week. We really appreciate your time. Next week's topic, Jake, if you just go to the next slide. Devin Gash will be leading us in talking about underground ductwork with AQC Industries. So hope you can join us for that. And again, thank you all for your time. If you have further questions or want to learn more about what we talked about today, just follow up with your lawn sales engineer. Thank you very much and have a great week.